Cool. Hello, everybody. Thank you so much for tuning into this stream. Today I'm going to be working on the Melodist some more. Today I was hoping to get into some editor, undo, and redo stuff because that's a pretty important quality of life thing for people working on maps. You know, it's really awful to lose changes and stuff. So I can go into the editor, you know, I can add stuff. But, you know, the problem is, you know, this does nothing right now. And that's obviously not too good. So I would really like to do that. Now, the good thing about this is, the way that I've structured the game so far is that all the memory is allocated up front, and everything just works within that block of memory, at least almost all the persistent state. Stuff like assets, you know, doesn't really, that's like allocated separately and stuff like that. Excuse me. But as for the persistent state that you're modifying in the actual editor, it's all just working within a block of memory. So what I was thinking might be a good strategy for undo and redo is actually keeping up basically a record of where the memory is written, how big that write is, and what the previous contents were. So for example, if I move an entity, that's like 4 bytes that changed or something. Now, if we start, actually, yeah, it's like 4 bytes or 8 bytes that changed because it's just changing like a floating point position, which is nothing, right? Because what I was doing before is I used to just be copying the entire map state to like a buffer and then just building up like several buffers, or building up several copies of the map, and that used like way too much memory, and that's just like not good. So I think it actually might be pretty reasonable to just have a record of like, hey, you know, when was the memory written? How big was that memory? What did the old contents look like? And then we can sort of just, if we want to undo, we just sort of step back in that history. If we want to redo, we just step forward. And that seems like a pretty good strategy to me. But I'm going to try it out, and we'll see what sort of problems we run into. Stuff like that. So we'll go ahead and introduce a new struct here. Editor, let's say editor state write record. And all we really need to do is keep track of where that write was. So write position, write size, and then we'll have like a void pointer that's like old write contents, right? And this void pointer should have enough space to cover write size, and then if we want to undo this action, we just copy the old write contents into the state, and then kind of go back one position in this sort of record that we have. So let's go ahead and think about how exactly we'd want to do this. So I'm going to introduce a function here that I can just call whenever I need to, you know, push one of these records onto just a big stack of them, basically. And effectively, I'm going to have to say which memory was changed. Effectively, I'm going to have to specify this information in this call, right? So I'll go ahead and say push undoable change or something like that. Actually, because it's all within the persistent state, I can just say, okay, address and size. So, and then it'll just actually save this off into this thing. And then we also just need to pass in the editor state. So effectively, we will need to allocate this somehow. I don't really care too much when it comes to making the undo and redo like infinite, like theoretically infinite. So I might just have like a big buffer of just memory that I can just allocate from. So what I'll do here, yeah, I can just put it down here. editor entity, or not entity, editor undo/redo information. And we'll just put a bunch of stuff in here. So we'll just have like a big buffer that's like, oh, like undo memory. And I don't know how big this should be. Let's say like kilobytes 512. And we'll just have a simple like little bump allocator that we can just pull directly from. And then we'll also just have an upper bound of editor state write records. And maybe just to be consistent, maybe I should just say write records. Whoops. There we go. And that should be pretty good. And then I don't know like how many we want. I'll just say like 256. Sure. Doesn't really matter. Write record count. And then we'll also have some notion of like where in this buffer are we. Actually, yeah. So write record position. And then we can sort of move this position around and just like move between different states by linearly progressing through this record history, which will allocate from here, and that should just be okay. And I'm actually going to move this like down here. So we push an undoable change. And basically what we'll say, first we'll just assert things to be true, and then we'll sort of go back and think about how we can handle these cases a little bit better. I'll just say first, I'll assert that the write records memory alloc position is like less than or equal to the size of write records memory. And then we only need to check that that's true for the alloc position plus the size. So we just ensure that there's enough space to allocate, and then we'll be good there. And then we'll say the editor state write record. We'll make a new one, so we'll say write record. And the first thing that we got to do is figure out the write position. Now, passing in a pointer for which address is being modified is more convenient. It's also a little bit like less obviously safe. So, but I think I'll take convenience in this case. Basically, we just need to ensure, right, that address must point to something within the game's permanent storage. And we can actually assert this to be true. We can just say, what's the offset of this address, right? So we'll take like a U8 pointer to the address, whatever it is, and we can just go to the permanent storage. Actually, this would be in platform. So we can just actually find out what the offset of this is, and we'll say, look, offset has to be, I guess I should really do I32s here so it can be negative. We should just say, I guess it doesn't matter, but we want to just make sure that it's actually inside the permanent storage. So we'll just assert that the offset is greater than or equal to 0, or it's less than the platform permanent storage size. So when we assert that to be true, we will just ensure that, whatever is in here is, or whatever was passed in is in fact in the permanent storage, which is what we want. Now, on second thought, it wouldn't necessarily have to be, but I can't really think of a case where it would matter. But I can revisit that if we run into some cases where it does. But I don't think it will. So the right position should just be the offset. And then we also need to initialize the right size, which is just size. Speaking of which, we should also make sure that the offset plus the size is less than or equal to the permanent storage size. And let's just do like a sanity check right here. If size is 0, then just don't do anything, because then there's nothing to actually undo or redo. And then we'll need to allocate the old right contents. So the old right contents should be, let's see what we got here. What is it called? Write records memory plus write records memory alloc position. And then we just need to bump that forward by whatever the size is, and then we actually have some space that's reserved for whatever like this thing is. And then all we really need to do is just copy into that space. So we'll just say, okay, write record dot old write contents. We'll copy into that from the address size bytes, and then we'll actually just be good there. So now we're building up this sort of buffer, and that actually will work. Now we can't undo or redo yet because this will just keep this write records memory will just keep filling up. Like, I'm not removing stuff if we don't care about certain points in history anymore. A good example is if you undo a few times and do something new, that's effectively branching paths. So at that point, we want to actually just start rewriting what was undone. But this is like a good start. So this makes sense. Now, what we want to do. So I think that's actually good. Like, this is a good thing to have. Now, I do have like a little command buffer that I build up in the editor, and undoed. Yeah, I don't know how to speak English, I guess. So I do actually have a little command buffer, and you can see it's just like, oh, editor action, undo and redo. So effectively, we just need to be like, okay, let's check if the write record position is greater than 0. If so, then we have stuff we can undo, right? Which is nice. So we can decrement that, and then effectively whatever we just kind of skipped over in the buffer, we want to do that action, or undo that action, obviously, because it's called undo. So so effectively, is this what modern forcoder looks like, or have you customized it? This is pretty close to just regular forcoder. It has like these scope highlights. There are a few things that I have that are custom. Like this is, well, first of all, there's my own custom theme. There's line highlights now, but there are like a couple things that I've done in my custom layer. I really don't customize it too much, but I do have a couple of nice things. Like, for example, I did take the thing that Alan wrote of like, oh, interesting. I guess that doesn't work in that case. But either way, like multi-line editing, like you can do that, and that's kind of nice. So there are a couple things that I've done, but really nothing too major. It's pretty close to just vanilla forcoder. So we'll just take a. So we're gonna find that write record that we just sort of are trying to undo at this point. So record to undo. We'll stay write records plus state write record position. I misspelled that, didn't I? Yeah, I did. Yeah, so that's what we want. And then we decrement the right record position, but we have this record and we want to undo it. So effectively, first of all, we're going to be able to assume that this alloc position, like, that should always be up to the point of the current record. And to maintain that property, we need to subtract whatever this record has. We need to subtract like the memory, the size of the memory that it's holding on to, basically, to ensure that we can write forward and we don't lose space over time. So we'll go ahead and say write records memory alloc position, and we're going to subtract the record to undo size. Why do I keep writing riot? Either way, we have to access that. Cool. So we've sort of bumped the allocator back for future undoable actions. And now we would like to just say, well, copy whatever the record to undo, copy the contents of the data it's holding on to into the address where it was originally copied from, effectively, which effectively undoes the action. So we'll go ahead and say destination address. And you know what, I'm just going to make this U8. And we're going to say it is the platform permanent storage plus record to undo, what is it called, offset, right position. So we have this. Let's go ahead and assert here as well that this is less than platform permanent storage size. We'll also just say less than or equal to, and then we'll add the size there to make sure the entire thing is in bounds. So that should actually, like, if we ever do something wrong, we'll know about it here. So the destination address, we get that, and we just want to copy to that address. So we'll just say, copy to the destination address the record to undo. What do we got here? Old write contents. And we want to I just realized that needs to be right size. So we'll just copy that memory back, and then we're done. And then we just move the position back. We already did that. And that's pretty good. Now, what we need to do now is implement this redo function, which effectively does the opposite process, right? So what we need to make sure of is that there is an action that can be redone. So effectively, we need to make sure that the current record position is less than the current record count minus 1, because that ensures that one write record will be at the end of the array. So then we can actually just go through and just take that action and redo it. And we know that the memory it points to is actually safe too, which is pretty nice, because it hasn't been overwritten yet. If it has been overwritten, then it's a separate action and this condition won't be true. So we do want to get the record redo here. Now, I'm trying to make sure that I have my indices sort of in order. Like, we have a position. Yeah, this is off by 1 because it's like then you can never undo the first array element, which is not correct. I like the idea of sort of thinking about it like a text cursor. Like in 4Coder, for example, you have like an entire character highlighted, but when you type, it's going to come on the left side of the cursor. So what I guess what I could say is like the highlighted array item, as it were, is the one that will be redone effectively. And then if we do an undo, then the one that will be undone is the one to the left. So we ensure that it's greater than 0, which is correct. But effectively, we also want to subtract 1 there. And I think that's correct now. But then, when we get the record to redo, it should just be the one right at the position. And then that should be fine. Now, so there is something, there's a problem here, because I'm storing the previous contents of a write record. But, I mean, effectively what we need to do is, I mean, if we have a bunch of records here, like we just have, and this is where the position is, like on this vertical bar here, these 3 should contain the contents of the memory that they want to change effectively. So we're not done with undo actually, because when we move back, we actually need to swap these 2 things basically. And then when we go forward, we just do the exact same operation. When we go backwards, we do the same operation, but we ensure that we swap this stuff. I guess we would have to swap either way. I think that makes sense. So we copy this to this. So we can just use the frame arena to do that. So we'll effectively say temp buffer equals memory arena alloc from the frame arena, and we'll do it with the record to undo write size. So we allocate like a temporary buffer to just swap these things. We'll just say, okay, well, I want to move to the temp buffer. From the destination address of the size that we're caring about here. And then we have to do a third operation here, which will copy to the record to undo old write contents. Except now that's not necessarily a correct name, so I'll just go ahead and say to do write contents as well. So we can just consider it either way. And the way we know which one is true is where the write position is, or where the write record position is, effectively. If it's behind us, then we know that we can undo it, and if it's in front of us, then we know that we can redo it. But the operation is going to be the same either way, so the operation is going to be the same. So we might even be able to merge these 2 cases, but I'll see. So we want to say we copy the old write contents, or I'll say to do write contents now, from the temp buffer, and then the size. And then do I have, let's go to the language layer, do we have memory arena free bytes? Yeah, we do. So we can just say free bytes, core frame arena record to undo write size. And we can just move that back because it's just a temporary buffer, so it doesn't matter. I mean, in reality, this thing is going to get freed at the end of the frame, so it doesn't matter, but I just like to do this if I remember to, or if I care to. So that's actually correct. Now, maybe instead of doing record to undo, I think I can actually merge these, and because they're doing effectively the same thing. Now let me just double check to make sure what I just said is true. So the destination address in the case of redoing is going to be where we would like to copy the modified memory, which is coming from... Yeah, it's the same exact operation. So I guess what I'll say is editor action redo as well. Let's get rid of that. And then we'll just have a few special things that undo does effectively. So what is this switching on? The action type. If it's an undo, otherwise it's a redo. And then otherwise, we have an invalid code path. So if it's an undo, I'll say position condition met equals this thing. And then in the case of redo, we want to make sure that it's less than the count minus 1 of the current write records. And I think that's all good. Cool. I'm gonna get some music going. Let's see what we got here. Okay. All right. So that should be pretty good. Yeah, drop frames went down to 3.5%. Yeah, I don't know what was happening earlier, but it seems to be good now. In either case, let me know if the music's too loud or something like that. Okay. So instead of record to undo, we'll just say like record to process. Whoops. So the record of process will get that thing, whatever it is. And actually, we should just do this. If we redo an action, we need to make sure we bump that allocator forward again. So we'll just say the music is certainly playing with my emotions. Feels like you're about to write the line of code that will change the course of history or something. That'd be pretty cool. I don't think it's the case, but you know, it's nice to think about. Is this from the game? No, it's not. This is a song finishing something you worked gets cut off, and Spotify doesn't like to have can't drag the title thing over anymore, so I actually can't tell what it says, which is absurd, like, really frustrating. Like, really, I'm pretty sure it's just finishing something you worked really hard on. Yeah, by Lullatone. So if you like the music, that's what it is. Although I do like the music, I would not be opposed to having similar things in the game for sure, at certain points. So we need to bump forward this allocator forward, so we'll just say bump it forward by record to process size. Now, we also have a redundant check of that there, but that's fine, I don't care. So we'll bump it forward by that again. And actually, yeah, pretty much the identical thing needs to happen here, except in the opposite direction. So I don't care about that. Actually, yeah, those should be in there. So undo, yeah. Record to process equals that thing. Increment the record position since we're doing an action now. Redoing an action, and bump forward the allocator. But in the case of undo, we want to bump back the allocator. So if the position condition is met, and we'll just say the record to process is non-zero. We don't want to do that anymore, but we do want to make sure that everything is still good. We get the destination address, we swap the stuff, and then we're done. So that's kind of nice. Now, there's something that I'm going to have to worry about, which is, you know, if we push, let's see, push undoable change. When we do this, we need to, well, actually, something right off the bat, but we do need to make sure that, that we actually store this in the right records buffer. But we also want to say, you know, we want to ensure that whatever the last change is like we can't redo after we make a change, because that's, like I said, that gets into branching paths, which gets ultra complicated. Most programs don't work that way anyways. So we'll just say, at least to my knowledge, like, I usually don't expect programs to work that way. Maybe there are some really sophisticated redo and undo stuff out there. I don't know. Either way, we're going to set the count to the current position, and then I think we want to increment the count and the position. So that should be good. I wonder if that'll actually work. That'd be nuts. Well, yeah, probably have some errors. Record process. Yeah, size is not a thing. I don't know why we keep doing that. Right record hour. Oh, memory. Hour position. Yeah, there we go. Okay, that was all. Now I did just remember something. I did just forget to. You know, maybe that's okay. I think that'll It'll be alright. So, you know, if we do this, nothing should happen. So it seems pretty good, because I haven't done anything, and I haven't pushed any undoable changes to anywhere. Move that down. Okay. Now it's just a matter of actually calling this push undoable change thing. So push undoable change. Let's try it when we like move the player spawn, for example. So push undoable change. We'll pass in the editor state and the address. So state player spawn and the size of the player spawn, which is just a 2D vector. Did I? Oh yeah. Okay. So we want to do it before we modify anything, because then it'll copy it and everything will be correct. Now let's see if it works. So we go into the player spawn, we modify it, we want to press undo. Okay, so something's broken. For whatever reason, it's like moving back. Interesting. Oh. It's doing it for like everything. It's like this will run out of memory at some point, I'm sure. If I just keep doing this. Because it's just undoing like every single tick. Yeah, that's not what I want to do. Yeah, good call. Yeah, I'm bad with names. I'm gonna say Croifa. Obviously, I've seen her name around, but I never have to say them with my voice. But yeah, fair enough. Music might be a little too loud. Maybe it's even a little too loud for me. Okay. So we're actually pushing this every single frame that the player spawn changes, which is not what we want to do. Effectively, we have like a thing in the editor. Oh, Croifa. Okay, awesome. So, where's this dragging? Yeah. So we have this dragging thing in the editor, and we'll just say, like, you know, if the state is dragging, so if the state's dragging, then do this thing. Otherwise, you know, otherwise just move the player spawn around. And if it's not dragging, we want to start dragging if the left mouse button is pressed. And then we also want to reset this dragging thing. So I'm toggle it back and forth. So it's actually kind of nice. So if I just do that, okay, so that's actually not working. Let me just think about this for a second. Well, I guess it's not going to undo anything. Yeah, I'd actually want to do this here. Yeah, because that's when the dragging begins. If you do it when it ends, nothing's gonna happen. There we go. There we go. And I can redo too. Now, I don't know if I can do the last write record, which, you know, is not great. But I can undo, so I'm undoing stuff there. Now, I need to ensure that I have these push undoable changes pretty much everywhere I want to undo something, but it does work out pretty well. There is something where it might increase complexity a little bit, which is the case where effectively you modify something like the tile map, or like the collision map or something, and you draw like these. Like the thing is, these tiles are actually like very far away from each other in memory, which means in order to have all of these in the undoable state, you'd have to do one of two things. You'd have to store every single tile between this tile and this tile, which is a lot, you know, because that goes all the way down here, because it's a row major. It's stored in row major form, so you'd have to go all the way down there to all the way over here, like every single row, all the way down to here, which is, you know, not great. Or you could store several records that are at different places. Now the problem there is that when you undo this thing, you want to just do it all in one go. So maybe there should be a flag inside of one of these write records that's basically like, don't stop at me, you know, keep going until you find one that has this stop flag set. So I think that'd be an okay solution for something like this. Better than probably saving all this stuff, because that really doesn't help at all. So I think that would be okay. Now, whoa, did not mean to test. Oh no, I'm go to a new map here. Okay. Okay, yeah, so we can't get to the last thing, which is not good. So I want to fix that first. So the position condition for redoing is that it's less than the count. I guess it actually, yeah, I guess it just should be less than the count, not the count minus 1. And then we actually should just be able to say, go to the last thing. Yeah, that works correctly. Perfect. Yeah, that's awesome. So now it's just a matter of kind of throwing in those push undoable change function calls around where I would like them to be. And yeah. Now, there are limitations to the system. So if something is more complicated than just reading or writing some memory, like if you have to request resources or something like that, that isn't gonna fly, actually. So that is a little bit more complicated. I think this write record struct may need to expand to sort of support something like that, but for now, I think that should be okay. So this works great for stuff like moving stuff or like changing tiles, which let's try that out right now. Or actually, let's try moving entities first, kind of climbing up the ladder of complexity here. So move, or I guess what do we got here? Update entity position. Yeah. This is what I want to push before. So editor state, well, I guess let's make sure that we're even. Yeah, okay. So editor state, push undoable action here. Passing the state, passing the address, which is just the field memory, and size of 2 floats. And the same thing for an IV2, except this will be for I32. And that's what happens when we update an entity position. Which I think might be everything we need to do for that. So that's actually, if that's how easy that was, that's like really great. So if I just do that, okay. Yeah, so like not wonderful, because that didn't work. But that works pretty well, so. But moving it, or updating entity position, for whatever reason, it's not fond of this. Let's check out the call sites of this function. It's just one place. That's usually not a good sign. Right. So if you let go of the mouse, it actually syncs the entity memory with its like rendering position, which is when this function is called. Which is correct, like that's when we would want to push the change, so and if it wasn't within the permanent storage, we'd be getting an assertion hit, so that can't be the case. Yeah. Let's check it out in the debugger. Yeah. Oh my goodness. Are you kidding me? Can I skip this? Oh, apparently I had a trial and it ended? That doesn't make sense. I guess I do have to sign in. I guess I should probably move that over here. Absolutely wonderful. Okay, can I use this now? It's funny how it jumped into the code and then brought that up. That's kind of weird. Anyways. I guess we're gonna want to go into here. And when we update the entity position, let's break here. So we'll go into that. Okay. So yeah, that's correct. What's offset? Something valid, I would assume, since the assertion wasn't hit. When we going to create a new write record. So let's go ahead and see what that write record looks like. Visual Studio does indeed often feel like a trial in a way. That's very true, unfortunately. I was really excited for CDBG, but I've been having some bugs with it, and Nick posted the last build because he's going to work at Rad now. So hopefully I can get my hands on the Rad debugger whenever it's out. So right position, got the size, and the old right contents. So what happens if we go to state and look at the write record? Write record count, position is 1. That's a thing. I guess. Let's observe what that looks like. 795. That sounds pretty reasonable. And then 236. Yeah, that's definitely the correct position. So that's the old position. And I moved that, apparently, to 795. So it looks like I'm just calling it incorrectly. But that's interesting because I'm calling it before the memory is actually modified. So that's kind of odd. I guess what I'll see is when this thing is called. So let's go into here, push and doable change. I know you can't find it. Okay. Move it. Gets called once. That's interesting. It's only being called once. It stores the field memory inside of the right. Inside of the right record memory. And has a size greater than 0. And then the memory is modified. So yeah, I mean, effectively the idea is you push this thing before it's going to be modified. Is something happening at the end of the frame that I'm like not taking into account or something? Because in this case, dragging doesn't take place in this frame. I wonder what would happen. Yeah, that's kind of nuts. Let's see what happens when I do this for the player spawn. Yeah, I mean, that's definitely correct. That is pretty odd. I guess what I'll say is maybe it's good if I try it elsewhere, because there might be something weird happening there that I don't totally understand. Let me try it somewhere else to see if I can sort of better understand what's happening. Entity dragging selection, so if it's dragging, if it's not, if it's left mouse pressed, then do that thing. Oh man, come on. Come on. Field memory. Oh, okay. Let's find out where the entity memory is. Huh. Oh my goodness. I'm a fool. I am an absolute fool. Just figured out what the problem was. Yep. Okay. Like I said, raising complexity, I suppose. The problem is that the notion of like an instance of an entity being rendered is different than the notion of an entity. And that's basically so the editor can do stuff with like introspection. So the rendering can be considered separately as just a separate thing altogether than entities like specifically. And basically it is undoing the actual memory, it's just not updating the render values. So that's a silly mistake on my part. In the case of the player spawn, it's just actually like this thing is drawn from the memory that's modified. So that's like correct. So I guess there are like two things that we want to care about here, which is effectively like I mean, the easiest way is to store two records. One for the render memory and one for the actual entity memory, which I suppose is reasonable. Yeah. I guess that makes sense. So cool. And we can't actually get the render memory from this, so update entity render. I wonder if we can actually entity render. So what we can do, let's back up the render as well. Now, since we don't have the sort of fall through things where since we don't have like non-stopping undo points, we'll have to undo twice effectively to actually move something. Yeah, still no luck there, which is not good. Let's make sure my theory is correct by actually inspecting the memory of the thing that's happening. So, so we're trying to update an entity position. Let's see. I don't want to. Actually, yeah, sure. So there we go. Let's find out what the type and index here are. Type, index, 0 and 0. Perfect. So here's an address that we can go to. Not sure what this is. Let's see what the fields are for static object. Static object. Yeah, so the position comes first. So that's what these 8 bytes are. So 1, 8. Oh, 8. Okay. So that's what these 8 bytes are. So if we just grab this pointer and cast it to an F32, we should get the position of the entity. Oops. Yeah, okay. So here's the position of the entity, and if we continue, then if we undo something, let's pause, and now they're back to where they were. So that is true. I guess I'm just not sure why the render isn't updating when I undo twice. So we do push the render as an undoable change before it's modified, which is correct. Ooh, whoa. Whoa, 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 whoa. Interesting. So then something goes nuts. just try backing up the positional data. That's interesting. It takes 3 undos, interestingly enough, which I'm not totally sure I understand that. Yeah, that's like that's an interesting issue there. Yeah, I need to sort of inspect what's happening here. Let's see what happens when we update the entity render. Cool. Oh, whoops. So I suppose that's not the correct place to update a render. The correct place to update a render is when it's starting to be dragged around. So let's push. Yeah. So we'd want to push the initial state of the entity render on before it starts being dragged. So as soon as the left mouse button is pressed, we would like to back up that entity render. Okay, so that actually did work. And that actually, so yeah. So 2, you have to press it twice because I don't have the fall through undos yet, but I will go ahead and do that right now. So we'll just have a B32 that's like, yeah, I like the kind of term fall through. And then it's as simple as saying, well, when we push an undoable action, we already have a bunch of calls to push undoable change, so we'll actually just overload that function. So we'll just say fall through, and then if this function is called without that argument, we'll just call push undoable change with a 0 for fall through, so that it stops for sure on this change, which is pretty much all the cases we have. Well, I'll have to go back and modify the entity ones, but that should be fine. Because if you just want to push a change, you don't care about whether it's falling through, unless you care about whether it's falling through, if that makes sense. And effectively, we just have to say, well, write record, fall through equals fall through, and then now we just need to actually handle that in the undo and redo code. So what we should say is while one here, and you know, if the conditions aren't met, then we break. But if they are, check to make sure that the record to process is a fall through. If so, break. Otherwise, keep going, and it'll just keep repeating the action, which I think should be correct. But we'll. There we go. Okay, so that's not totally correct. Fall through actions don't. Fall through is 1 for all of these. Oh no, that's incorrect actually. Okay, that makes sense. So it actually went back to the first. So if it's not a fall through, then break. And then when we move around an entity, push undoable change. So before we do this, we'll have this be the persistent one because it happens first, right? Well, no, I suppose it doesn't. So yeah, it doesn't happen first. So if we push this one first, we want it to stop here. And this one happens last. So we do want it to be a fall through case actually. So fall through there, and then when we push doable action or change, whatever, make this a 0 for a fall through. Because this happens first and we want it to stop there, right? So it's a little annoying that we have to care about the order, but there we go. There we go. Cool. So now we can undo the positions of entities, which is really, really nice. So that's super duper swell. Let's also do it for adding an entity. Now that's a little bit more complicated because we have to keep track of many things that change. For example, the count, so how many entities there are, the new entity memory, all this sorts of stuff. So we have this add entity thing. Okay, so we have a nice little function called add entity. And before this happens, we want to push some undoable changes here. So it should start before we start modifying the field memory. So we'll go ahead and say, okay, well, we're about to do some stuff to the field memory. So back up the field memory. Now, how big is that? Well, it's just however big the entity is. So size per instance. Push that change. We're also going to push the count before that happens. So count plus plus. Here we go. Push that. Entity instance. That's type dot count. We'll want to back that up. Oh. What in the world? Why is that copy? Okay, weird. Anyways, so we'll back that up. And we want this to be the one that it stops on because it's happening first. So fall through 0. In this one, we do want it to fall through. And now if I add an entity, I can undo it and redo it, actually, which is super, super cool. But I don't think I'm done, because when we update this entity render, one of the things that can happen is a texture can be requested, or released, for that matter. And if we undo, this action would need to be undone as well. So that's sort of a problem. In which case, this write record, I'm almost thinking should have been called undo record. Although before I get to that, let me do tile stuff. So let's go into collision. Yeah, here we go. I even have to-dos for it. Look at that. I can get rid of those. So if the left mouse is pressed, we're about to start drawing collision. Editor state, yeah, this is the old thing that I had, which was way simpler for an API, but it saves way more than it needed to. So we'll say editor state push undoable change. And we're going to have to go through all the different rows. So we'll go ahead and say, well, so that's interesting. We don't actually know. We don't know what rows will be drawn on. So that... Interesting. Okay. So the point is, it doesn't... Like, memory access patterns aside, it doesn't matter which row we really take care of first. So every time the mouse tile X or mouse tile Y changes, we can back up that row right before it starts drawing on it. So in this case, we'll want to back up the row, not even just the row, I'm saying row, I just mean that tile specifically. But we don't actually know, we don't know how many tiles will be drawn though, so we'll actually have to back up every single tile. I don't know how big of a deal that is. It's probably not that big of one. But I guess it's probably good to start that way, just for simplicity's sake. So we'll go ahead and say, we need to know if the mouse tile changes, so what I'm going to do is actually just say, well, we do have a last mouse X and Y, so we can just derive the mouse tile from that, the last mouse tile. Actually, whoa. I don't want to change that. Yeah, I guess I'll just back it up. I'll just have it there for whenever I need it. Cool. So we just back that up, and now we have the last mouse tile, and we can change if it we can check if it changes, and if it does, then we need to back up a new tile. So first we need to back up the first one, which will be our non-fall through case. So we'll go ahead and say state map collision tiles plus state map width. What is this? I'm reading up here. What is J? Oh, that's like the clipboard stuff. Okay. Cool. Plus map width times last, or actually mouse tile Y, and then size of one map collision tile. Oh, also mouse tile X. And then if drawing is happening, we'll say, okay, well, is mouse tile X different than the last mouse tile X? Or is mouse tile Y different than last mouse tile Y? If so, we'll push. I guess we actually have to push. Oh no. Oh no, that's fine. But we do need to push every single row of the clipboard. So we go to the first row. We go to the first row that's going to be drawn on, and then we add the mouse tile X. And then we want to do this for the entire row. So the width times the size of a map collision tile, and that'll actually just save the entire row. We don't know what the fall through case is though. Or we don't have a non-fall through case to back us up here. Like a piggy way to do it would just be like right when it starts drawing, then do it for like just the tile that the mouse is on or something, and then it'll just overwrite it anyways, and it's gonna be fine. And that's probably okay. Let's see if that works. Oh, I need to actually make that a fall through case. Or well, that's not a fall through case, and this one is. Here we go. Come into here, check out collision. Yeah. Okay, so that one, yeah, that's not correct. So maybe because it'll do this one first. Not sure what to do about that totally. Well, since this would happen in any case, maybe I want to flip that when I actually undo and redo. Let me see if that's going to work the way I think it will. So, if this thing is a fall through, or if it's not a fall through, well, we don't want to change it. Yeah, that's like not straightforward. Maybe it's not enough to say, it might not be enough to have the ability to fall through. Maybe, maybe there needs to be something else. Or maybe it needs to be like a fall through type or something like that. I guess I do. It would be nice to like guard off a set of write records and just be like, don't do anything with these. but just know that these are the beginning and end of some action. That would actually be pretty nice. So maybe it's not a problem to have a size of these things. Okay, so here's the thing. With the write records, we're going to have to introduce different types of write records, right? We're going to have to worry about stuff like, was a texture requested? Was a sound requested? Something like that. So we're going to have a concept of different types of write records. Anyways, I like this song. What's going on here? There we go. So let's kind of introduce that concept right off the bat. So editor state write record, max, and we'll just say plain memory write, texture request. Well, yeah. So this is what we've been dealing with. We'll also have the ability to request textures or release textures. We'll also have a dummy thing, which just stops things. Now, call them start group and end group. And instead of fall through, maybe I should just say type. Okay. Yeah, that makes sense. So we sort of have this concept of a type, and if it's a plain memory write, we do what we've been doing. If it's a texture request, for example, then we will do that accordingly. If it's a texture release, then we'll release it. Stuff like that. So we're gonna get some errors here. So instead of fall through, maybe we should just say like, what's the, actually, yeah, so push and doable change, we'll just have a type that we can pass in, and then a texture that we can pass in, and then we'll just have a bunch of helper functions that call this in convenient ways. So for example, push and doable change with just memory is probably just a plain memory write. So editor state write record, plain memory write, and a 0 for a texture. If it's just a texture, well, we don't know if it's request or release, so we'll just have different calls for that. Okay, so we have these different types, and we have some things that we can call that are sort of convenient for us. We We can also just have a start group and an end group just with nothing. Okay. And, well, with address and size, it should just be 0. For all of these, actually. And we shouldn't care if size is 0 now, because it can be other stuff. Now, we should care when we try to allocate to back certain memory up. But I think that's all. Yeah, I think that's all we really need to care about. I guess we should make sure these asserts aren't hit. If size is non-zero, then we just need to make this assertion, and then this should just work. Cool. So that's just like incorrect, right? And this is actually, this was like the dummy thing we did. So we can actually just be like, oh, you know, I want this to be the start group. In which case I just have to pass in the state. And then when I let go of the mouse, that's when I'll put the end group. So drawing equals 0, and then we'll push a start and end group there. End group, is that not defined? Oh, end start group, yeah. Change end group. Whoa, what is happening? Okay. Whoa. Alright, now we'll go into the entities. And we push this undoable change here. And we wanted this to fall through. Yeah, that makes sense. I guess I don't like this being separated from the rendering undo stuff, so let's just get rid of this for now. And then address it later here. Oh, that's when we add an entity. So that's actually... So we actually want to push start group and an end group here. And we don't want it to fall through at all. And we push entity dragging and selection, so this is where we sort of start the thing. So we'll start the group here. Back up the render. And we also want to back up, well, we have the type and index, so we can find the correct entity instance memory. So we can actually just back that up too. In which case we can just say something like, oh, instance sets dot type dot memory plus index times. Get the address of that. Index times state entity types type dot instance per or size per instance. And we want a backup size per instance. So that's actually what we want to do there. And then we just want to end this change group. 670. Oh, void star. Let's go to the editor. 2172. So yeah, now we just need to handle this thing. We'll effectively be like, well, we have a record, we can get it to process. So if the type, editor, state, write record, end group. So if it's an end group thing we want to break, but if there's only been one action pushed, like then we want to break two. So basically we should say like, oh, E32 waiting for end group equals 0. And then we'll say if record to process type is error state write record start record group then we'll say we're waiting for an end group. Yeah. I don't know if this is going to work because I'm not totally on top of it. Okay. Ooh. Okay. It's not totally correct. Oh, right. We want to end there as well, so let's test it out. Perfect. Yeah, that's awesome. So that works good. Now, let's worry about collision editing, see if that's all kind of working. So we come into collision, let's do this. Okay. So that's not correct. Whoa. Right record count. Yeah, that makes sense. I'll sort of have to worry about, like, sort of allocating more if necessary there, because that was, like, nothing. Like, that did not take anything at all. Well, I also like what? I only have, like, 256 of them. Let's do, like, 8192 or something. Hopefully that's, like, good size-wise. I guess do I assert that that's the case? State types. Yeah. State SCP. When I generate those calls, do I, assert statements. State memory size greater than, yeah, okay, that's great. Absolutely wonderful. Whoa. Yeah, that's not correct. Okay. Huh. Just going forward too far, which is interesting. I wonder if it gets caught in a loop because it doesn't find an end group or something. So it does seem like the start and end groups are just not working. I guess it's because... Yeah, that does make sense. When you undo, you're gonna hit an end group first. So I don't think my thinking was totally clear on that. Yeah, because we need this system to be bi-directional, effectively. So maybe it's best to have, like, sort of... Instead of start record groups, like, barriers instead, I guess. But we could actually just do that by, like, saying... we're... set that equal to this thing. Although that's not going to work. Because I have like an else case that depends on the difference between those two things. So, first I'll say like, oh, are you waiting for an end group? Otherwise, if you're not waiting for an end group and you find a start record group, then it'll be 1. Otherwise, we're going to break. If we are waiting for an end group, then we're going to want to find one of these again. And then we'll break there. Now, might work now. So that still works perfectly fine. Non-grouped changes work. Let's see what collision looks like. Nothing. Absolutely nothing. Yeah, so that took a lot more, but still, it's not good. Either way, it's not working like either way, so. Well, I guess these don't have any memory associated with them, so this is trying to copy like 0 bytes. Or I guess what I'll say is, only do any of this stuff if the right size is non-zero. So that should still work just fine. Forward, backwards. So we'll do 1, 2, 3, back 1, here, back 1, forward. Perfect, okay. Now, let's try like an entity, for example. Oh. Oh, yeah. Something's wrong here. So we're not waiting for an end group by default. So, and if we find a start record group, then when we say we're waiting for an end group, which means on the next thing we'll be looking for it. And if the type is an end record group, then we set it to 0 and break out. Which to me makes sense. Ooh, I guess, okay, yeah, that makes sense. Okay. Yeah, so the group thing, not going too well. So, in collision, for example, when it's not drawing and the left mouse is pressed, we want to start drawing. So we push a start group, and then as we're drawing, we push all these different changes. If the mouse is down, because that means we're going to modify the actual tile map. So we go through each row, make sure we push every single last row as an undoable change. And then, if the mouse gets released, then we push an end group, which seems correct to me. So, whoops, that's not what I wanted to do. Okay, collision, let's do like this. Oh. Okay, so it does actually undo one tile at a time, except for the last one, interestingly enough. But we can't actually just go through. Yeah, so the groups aren't working, but they are, those things are happening. So let's actually, first, let's actually make sure that those right records are even getting pushed, because I might have a case that prevents them from getting pushed. Push, undoable change. So if the size is non-zero, we care about this. Otherwise, we just go through. Offset. Address is 0. Should just be 0 anyways. So 0. Otherwise, offset is this thing. We set offset, size, old right contents. That's fine. Set the type, set the texture. If the size is non-zero, then we, do the swap thing. Make sure there's space in the right record thing. If so, then add it to the right record buffer. So that seems okay. It's got to be in the processing of them, I believe, then. So if there's a right size, then we swap the memory. Otherwise, we... might want to debug this. I'm going to debug this. I don't like using Visual Studio, as most people who like their lives. But I need to comprehend this a little better. Whoa. Is this... Oh my goodness, does it not reload it? Can I... Okay. There we go. Let's go and see what the write records look like. $61. I guess that makes sense because there's like a lot of tiles being drawn here. So interestingly enough, I do not see a start group. I see an end group. This is the end group, but where is the start group? Yeah, 1 byte. That's a collision tile. These are all 1 byte, I'm sure. 1 byte, yeah. And here's 3, and if we check what 3 is, 0, 1, 2, 3, which is correct. So I don't know why the first thing isn't getting pushed. I'm gonna see if this ever gets called, and then I'm gonna check out what happens there. So, go to collision. Come on, Visual Studio. Collision, thank you. So this is the call that should be happening, and adding a start group. Unless, of course, like... No, yeah, that should be fine. Okay, there we go. Step into here. Oh, no, I don't want it. I don't care. Oh, no. Can I just keep stepping? Goodness gracious. Okay, so what's the type here? Type should be 3. Type is 3. This assertion should pass. The offset, don't care. Oh, write record position needs to be incremented. Oh my gosh. Okay. Oh, I see. Okay. Alright. That does make sense. Okay, now... Ah, so this one's still there, but... If I were to do it like this, some of this... Now it does leave the first tiles, which is interesting. Not totally sure why that's the case, but either way, at least it's kind of working now. Let's see if we have a static object. Yep. And then if I redo, I can just pop it back in. That is absolutely awesome. Perfect. That is super cool. That works really well. So now, I have to worry about these things. I don't know why those are there. Like a start group shouldn't do that. Nothing like that. Undo for the win. Yes. I'm very happy about that. How well that went. Little humps that I had to overcome. Coming up on 2 hours for the stream, so that's not too bad to implement like a nice little undo and redo system. It's not perfect, it's not airtight, but it does seem to be working. Now, why, however, is this the case? Like, why? Oh, I see. Right here. That's the problem. I'm just gonna duplicate it. I don't care. Just gonna duplicate the code. And then it'll actually probably work fine. So, if I do this, yep, there we go. That is perfect. Awesome. So, if I were to open up like an existing map, like map, I should just be able to use undo as I want. Perfect. That is awesome. And then if I come here and then move it here, then I shouldn't be able to go further. Perfect. That is awesome. So groups are working. Now I would like to get the texture requesting and unrequesting or releasing working as well. So for example, when an entity render is updated, like there is a potential release and request of a texture, in which case might want to dump the undo state to a file. Yeah, definitely. That was sort of my idea, if I did want like infinite undo. Granted, I'm not sure I'm going to care. Like it might just, I could just make it big enough that it never matters, really. But it would also be nice to have infinite. So maybe that's a good option. And just have like a sort of temporary binary file that you can stream in and out of for undo history. That's probably the best option, actually. Just with the just the fact that like the tile editing just takes up so much memory. So yeah, I guess it would probably make sense to sort of do that. But I am gonna first. Yeah. Okay. So. Okay. Persistence might be nice. Interesting. Yeah, that's not a bad idea, actually. Yeah, I could definitely see that being useful. If you open the editor back up, or if it crashes, especially. Yeah, that's a good idea. I'll definitely do that. So the change start group. That's when an entity is added. And then I update a render. When do I put the end group? Where is that? So I actually don't want to end the group yet. I also want... Yeah, okay. So when an entity render is updated, I'm going to want to handle this case. What I'll do for now is like error state update entity render expects that a undo group is present. That's gonna, yeah, that's actually really fun. Let me do that. Just so I never forget. I'm definitely gonna forget at some point, but active makes more sense. And then effectively I'll say editor state push change request or release actually state and then the render texture. And then the texture. Okay. The new texture, I should say. And then we can just actually handle that case pretty easily. New map, no. So if the right size is non-zero, let's also check if the texture, then we should check if it's a request write record, then we want to, it depends on whether we're undoing or not. So you know what, I'm sick of checking like this thing, so I'm just gonna be like action type equals this thing, and I'm just gonna say like, oh, if undo, then we want to unrequest, right? So we'll say assets release texture. Otherwise, we want to request it back, basically. And then for release, we do pretty much the exact opposite. Now it should just be the same pretty much. Perfect. That's awesome. Let's do it for removing entities as well. Entities. Remove entity. So we're going to want to back the last value, the count, the last entity instance, the entity instance that the last one's being swapped into, and the count. So we'll just want to do editor state push undoable. We'll change start group. And then start and end group. And we'll want to say, well, back this up. Also back the last one up. and then also back the count up. Cool. So let's see if that works. So I'm gonna delete this thing, undo, and there we go. So the entire life cycle of an entity can just be reversed right here. That's pretty darn nice. So that's all good. Let's double check that collision's working all right. Just in case change might have broken it or something. If I do this. Perfect. So that all works. Let's worry about the tile map as well now. So it's pretty much the same story as collision, because collision and tile map editing are both like super similar. So for drawing, the left mouse is down. Just like make sure to back everything up, you know. Instead of map collision tile, just a map tile. Instead of collision tiles, just the tiles, and that's all good. Although we do need to worry about the layer here. So state. Tile edit layer. State width. State height times this thing plus this stuff. And that should be fine. So that'll actually back it up. Although I do need to worry. Cool. So now let's see if tile map editing is the same way. Oh, I didn't do a group. That might be a problem. Whoa. Yeah, that's not right. Gradifa, so the game is music themed. Do you have a passion for music? Yes. You might laugh when I tell you, but I actually played. It's like most people think it's like the least musical instrument. But I played drums. I played jazz drums. But I also, I don't consider myself like a pianist, but I do mess around on the piano. I've always had a really great interest in chords and the relationship between chords, and how like I always found like literally like two different chords that just sounded cool to me. I just found that sort of like a fascinating concept. So and I sort of wanted to capture in the game the relationship between, not only have this interesting symmetry between the physical world and music, but also the story is also about how music interacts with your emotions, and how it can provide nostalgia, remind you of something that maybe you didn't want to think about, or maybe that you did. I've always been like Really, really interested in that. Just really simple stuff, like just two simple chords and how they just move is really interesting to me, because it can just invoke so much emotional stuff, even though it's like, 7 notes or something, so yeah, I just feel like there's a lot of great emotional power in music, and that's like partially what the game is about. So, not totally sure. It could be the case that this is just wrong. Do I have a platform? Oops. Oh, come on. I don't. I use it enough that I'm going to introduce it. And then Melodist SCP. Load data from platform. We'll just say core last mouse x equals, or no, platform mouse x equals platform. Huh. Yeah, that's not right. Oh, well, I guess it's... Yeah, that doesn't make any sense. We want to end the frame. Put it there. Tiles. Yeah, what in the world? What happens if I only have one tile selected? Oh my goodness. Did I do the thing? No, I didn't do the thing. Oh. Krifa, neat. It sounds like it's going to have a strong narrative. Thanks. I mean, I don't know if you mean strong as in like a big part, or strong as in good. I'm kind of... If you meant good, thanks. But if you meant a significant part of the game, yes. Although I don't want to like shove it in the player's face. Like, it's going to be minimalistic for sure. Like, you'll see things, but they'll sort of be like disjointed from everything else. So it's not going to be necessarily like, oh, you're just following along this story. You're going to see different pieces of like a big overarching story, and how you piece it together. It's all up to your interpretation. Game will probably be different, but have I played any other music-based games? I've not played either Circuits or Fract. I've played Guitar Hero, I guess. I'll look that up. Circuits game. Let's see what we got here. Oh, I've seen Circuits. I have seen Circuits. I haven't played it. It did seem pretty cool. And then I don't know what Fract is. Fract game. I don't think I've seen Fract. Musical exploration game. Interesting. Oh, my speeds are really going down. Oh, interesting. Oh, that is awesome. Yeah. Cool, yeah. I'll definitely have to check that out some more. I just like the look of it just from sort of the music that was playing in the trailer. So that was pretty cool. Yeah, I'll definitely check that out. But I have seen Circuits. Circuits looked pretty cool. Yeah. Yeah, mine's a little different in principle, but similar, I guess, similar idea of like music in the world being sort of just like symmetric in a way. So last, cool. Let's see if tiles. Okay, same thing happened, and that's because I just need to do this when drawing starts. Whoops. So, we're going along, editing some tiles, we put these down. We're like, oh no, I didn't want to make the map look terrible. Yeah. Sweet. Perfect. So that all works pretty good. So we have tiles, we have collision, we have player spawn, we have entities, camera focus regions. That's an entity now. This shouldn't even be in this list. What am I doing? Oh wait. Camera focus regions. Where is that at? Editor mode, like, get out of here. Strong is well defined. Yeah, that makes sense. Yeah, and it's interesting that you bring up braid because it's like, obviously it's an inspiration for me. I mean, it's an inspiration for everyone, but yeah, I'm glad you characterize that as strong because it's, even though it's heavily like narrative oriented, it's not like linear sequence of events narrative. Like, it's just like, hey, there are these out of order, interesting sequence of things that you piece together yourself. And that's sort of what I'm going for. In a different way, because Braid just had the books, basically, and it had like imagery and stuff. The Melodist will have like cutscenes. In fact, I've shown one before. I don't think it'll actually end up being in the final game. Something similar will be, but not the one I showed in particular. But you can probably check it out in one of the older devlogs, because it's probably somewhere. Cool. So anyways, player spawn good, entities good, game settings, that's not a thing yet. Editor settings, this doesn't do anything, because I like leaving things unfinished. I could have this undoable, but like, there's just no point. Like, oh, you accidentally changed from cave. Like, just change it back, you know? Not a big deal. So that's pretty good. Nice. So, the editor does have undo. It's not perfect yet, though, so I guess what I'll do... Yeah, I'll start saving stuff to disk. I think that's a good idea, because it's nice to have it persist, and it's nice to just have it be infinite. So what we'll say is, like, you know, we have this undo and redo information. We can actually just make this way smaller, like 1024 or something. And if this fills up, we can just write this entire thing to memory and then be good. So instead of asserting that we're out of, that we don't run out of space. We'll say, oh, if we are out of space, then we'll have a quick to do here, save to disk. And then, then we'll save it to disk, so that'll be good. And then we also need to find out when to stream it back in, effectively. Save to disk and reset. Basically, you would want to check for something on disk. If you're undoing and you hit like the lower bound of things you can undo, or if you're redoing and you hit the upper bound, then you want to load from disk. Although, yeah, that might be a pretty big time investment. I might just want to end on undo and redo working well. And then I can, next stream, I can actually work on saving undo and redo state to disk. But I could do something a little bit quicker. So my to-do list, editor undo and redo, let me add a little task here. Whoops. Okay. Now something else that I needed to do really quickly was having non-chordal background music patterns. So effectively, if we go into game data developer background music patterns, you can set a bunch of different chords that can play when a certain, or a bunch of different sounds that can play when a certain chord is reached. And that's all good, but sometimes you want things that are non-chordal, like percussion, for example, or birds chirping, or something like this. So I want the ability to be like, name, like birds 1, or something. Like environment, forest, sound, like bird sound, whatever. And then chord, like, I don't care. Or like, just 0, like 0 would work. Or any. I'll say any. I approve of celebrating small yet significant victories. Yeah, I don't want to end in like the middle of doing something, because it's like, that's annoying, you know? So I think I'll finish this up. What am I? About 2.5 hours right now? Okay. Oh my goodness. So yeah, I'll finish this up and then I'll be good to go. So, we have birds 1, which is not a real sound, but let's say it is. We want it to play for any chord. Well, we have a chord list. Let's see, chords and notes. We define this big chord list. What I would like to say is, define chord any as like -1 or whatever. And when we parse, did I just type parse? Man, my brain's going today. Let's see. So when I parse the background music pattern data, you know, we look for a chord. Right, so we actually do get the name. So we can actually just, so we eat the string, get the chord string. We'll just say, okay, if string compare case insensitive chord string with any. If that's true, then we'll just say, okay, the chord we're talking about is chord any. Otherwise, let's find the chord. And I just do like a linear search because like whatever, there's not that many. I think this might be a bug in 4Coder. Like, I don't know why. Maybe not. Maybe that was always like that. I don't know. Either way. So if it's any, then chord any. And then in the game, when we're updating, background music. Is that a thing? Yeah, here we go. If pattern. Okay. Here we go. So if it's the correct chord, or it's chord any. And that's like a nice little hack that we can just throw in. Maybe I'd want to handle them separately. Yeah, see, active chord would have to be greater than or equal to 0. I don't like that. Yeah, that should be separate. So like background music stuff. Seconds to next non-chordal BG music pattern. Because that has to be different to sound good. Five. I don't know. Sure. Whoa. Okay. Rule of 3, I'm going to copy and paste this. Pattern index. This. Start pattern index equals this. We're just going to go along here. If the chord is chord any, then we can just we don't care if it was the last one for now. And then non-chordal things, yeah, I'll just say it's background music. That's fine. Cool. So that's all good. That's what the game looks like if you're running on a bad computer. Anyways, I really hate that. So, okay. let's throw in like a test any chord clip. So background music patterns, let's be like test, test, any, and then background music sets, we'll throw this in as one of the patterns for the background music set of Forest. Oh, I should also check state game. Ooh. This should only be true. This should only be checked if it's if that's the case. It should only be checked for chordal background music things. Okay. So that's all fine. Let's find a test clip. Well, I guess for test I could do like, I don't know. I guess I have like button. Let's see. Melodist game data sound. Am I like... Oh, okay. I'm listening to Disaster Piece Fez music, which is like chiptune, so I couldn't even tell that the jump sound was playing because it's like that kind of a style. Let's do button. Let's do button. Yeah, button's fine. Okay, now let me turn off the music and see if we hear it. Yep, there we go. I don't know if you could hear that on stream, but it did definitely happen. Wait a minute. What? Why in the world? Why would you ever be playing C major stuff? No notes have occurred. Yeah. No chord history. Let's see. Let's see where that's being played from. Yeah. It's being played from here, which is not correct. Oh, because it resolves on 0. That makes sense. It ends up resolving out a pattern, even though none of them actually match. I would think. Although I don't know why that would happen like that. Ooh. Okay. That should actually fix it. So there's the click, like birds chirping or whatever. Yep, there we go. There we got the button. And we are all good. Cool. Okay, that's gonna drive me nuts. Let's get rid of that. Okay. That being said, I'm gonna wrap up. I don't know if anybody's still here. If so, feel free to ask any last-minute questions, and then I will go ahead and jump off. What's going on here? Okay. Why did that still happen? Oh, okay. Those particles do not look good. I'm gonna have to figure that out. All right. Doesn't look like there's any questions or anything like that. So I'm gonna go ahead and wrap up. Oh, man. Cool. All right. Turn this down. Make sure it's not annoying. Cool. All right. Well, thank you everybody for tuning into the stream, both now and later, for the recording. Thanks for tuning in, Karifa. Yeah, I will catch you guys later. Thanks for tuning in and watching some more development on the Melodist. See you guys.